trigonometry. I'm wishing you well. Hope you are doing good. Let's get started on our second assignment for this week. It is week 5. It is the second assignment. It is 5.2. We're going to do some quick just review because now we've talked about all of our trigonometric ratios, the basic ones. We've talked about tangent, sine, and cosine. Just remember, hang on. Just remember that our little mnemonic device, SOHCAHTOA, is going to help you remember exactly which two side lengths in our right triangle that we are comparing with a ratio. Honestly, I have to write those down, so that is my little cheat sheet. Please keep that tucked in your brain. Let's just look at this triangle. I got a basic 3, 4, 5 triangle out there, and I'm asking you to find the tangent, sine, and cosine of angle A and angle B. So we're going to do some little review here. The tangent ratio of angle A, again, tangent, I'm just going to look at my mnemonic device, opposite over adjacent. And if we're looking at angle A being our reference angle, I'm just going to add a little theta down here. We're looking for opposite over adjacent. Well, the opposite side to theta is 3. The adjacent side to theta is 4. So we have a ratio of 3/4. I almost said 4/3. 3/4. Sine, I'm going to look at my little mnemonic device, is opposite over hypotenuse. So the side that is opposite of theta is 3, and our hypotenuse is the side that is opposite of the right angle, is also the longest side, and our longest side here is 5. So I have a ratio of 3/5. Cosine, that last one there, is adjacent over hypotenuse. Isn't this so nice? And then you have like all of your things written down from these. I love those. Adjacent over hypotenuse, so I have an adjacent side again of 4 over that good old hypotenuse of 5. All right, now let's switch to looking at angle B. So now I'm going to move my angle theta over here. I'm going to move it to angle B, and we're going to do the same thing. So now looking from angle B, my opposite side is 4. My adjacent side is 3. For sine, my opposite side is still 4. And my hypotenuse, still 5. And then for cosine, my adjacent side is 3 and my hypotenuse is 5. All right. So one thing that we could notice is that, well, the 3/5 and the 3/5 here are the same. And I also have the same ratio here. The 4/5 and the 4/5. So what exactly does that say? That says that the sine of one acute angle is going to be the same number. It's going to be the same ratio. It's the same measurement as the cosine of your other acute angle. Pretty darn cool. Nice and handy. All right. We're going to move on to inverse of cosine and sine. Again, this was talked about in section or in assignment 3.2, I believe. So it's the same thing, but now we're just going to be doing inverse with sine and cosine here. So again, I have my ratios written out from my table here. Sine of A, we're just going to use A as our reference angle here. So sine of A is opposite over hypotenuse. So I have this length of A over C. The inverse, all right, so this is the new part. The inverse of sine looks like this. It says sine, and then we kind of put this exponent of -1 to indicate inverse. What the inverse function of sine does is it takes this input of your sine ratio, so A over C, and it will give you your angle measure. So it'll tell you what the angle measure is, all right? And again, we're going to see some examples with this. I just want to get this table kind of filled out here. Cosine of A again for inverse cosine. Oh, I'm still looking at that reference angle of A. So inverse of cosine looks like that. It takes an input of your cosine ratio, B over C, and it will tell you what your angle measure is. All right, so it'll tell you what the angle measure of A is. Let's move on to some examples. We're going to put this to use real quick. I'm going to show you how to do it on your calculator if you have a calculator with you. Otherwise, please use those online calculators that I've posted in the materials section. It's underneath the classwork as well. So inverse sine questions, find the measure of theta in all of these. So in this triangle, I have a reference angle of theta here. I'm just going to set up a sine equation, and then we'll see what we can do there, right? So from here, I can already write sine of theta equals, again, sine of theta is opposite 12 over my hypotenuse 22. So my inverse sine inverse, is going to take an input of my sine ratio of 12 over 22, and it's going to tell me what my angle measure is. All right, and that's something that we can plug into the calculator. I'll show you how to do that in just a second. Or if you want to think about it, if jumping from here to here doesn't make any sense, you could think about trying to solve this equation for theta, right? If I wanted to solve just for theta, I have to get rid of the sine. Well, how do I do that? We're just going to do the inverse function of sine in order to like cancel it out, right? So essentially what I am doing is I'm taking the inverse of sine on both sides. So I'm doing sine inverse of sine of theta equals sine inverse of 12 over 22. Because what you do to one, what you do to one side, you must do to the other, correct? So I would have to take the sine inverse on both sides in order to cancel this sine ratio here. Well, sine inverse and sine, I mean, it's the inverse function. It's going to cancel each other out. So you're just going to be left with this sine here, right? So now I can say, you're just going to be left with the theta. I'm sorry. And so then I'm just left with theta equals sine inverse of 12 over 22. And that's the same thing that we have here, right? Let's see how to plug this into our calculator in order to evaluate for that angle measure of theta. Okay, this is how you get to inverse sine and inverse cosine. We've done this before with the tangent button. The inverse tangent is located right above it, and we had to use second and then hit that button to get the part that's right above it. Anyway, we're doing the same thing with sine. So if I hit the second button, sine, and then I can type in the sine ratio, and our sine ratio is 12 over 22. So I'm just literally going to type in 12 divided by 22. I like to close the parentheses, and I hit enter, and I get 33.055. On these ones, it's the same process. My inverse sine is located right above my sine button, so I'm going to hit second. I'm going to hit the sine button, and now I have inverse sine. Type in 12 over 22, close those parentheses, hit enter, and I get the same number, 33.55. For inverse cosine, it's the same thing. I'm going to hit second, and I'm going to hit the cosine button here. All right, we'll use that in just a second. So as we saw, if we put in inverse sine of 12 over 22, we got a theta, we got an answer out of about 33.055 degrees. All right, let's move on. Let's do two more examples together with inverse sine. So here I have a right triangle, and I have a opposite side of 48, and I have a hypotenuse of 73. So I'm just going to set up a sine equation here and just say sine of theta equals opposite over hypotenuse equals 48 over 73. And then, like I said, essentially what we're doing is we're just solving for theta. So to solve and just get theta by itself, I have to get rid of that sine, and so I'm going to take the inverse of sine on both sides. So I'm going to say inverse sine of theta equals inverse sine of 48 over 73. And again, since we took the inverse of that sine function, it's just going to cancel it out, and we're just going to be left with that theta. So theta equals sine inverse of 48 over 73. All right, and then that's something I can type into my calculator, make sure it's in degree mode again, and you're going to get a theta of 41.11209 degrees. All right, so that means that this angle right here is about 41 degrees. Okay, last one over here, I got a nice 3, 4, 5. Oh, well, we could solve for the other side length. It would be a 4, but it's a 3, 4, 5 triangle. Anyway, here's my right angle. I forgot to add that. Let's just write our sine ratio equation out. So sine of my reference angle is opposite length of 3 over my hypotenuse of 5. Again, essentially we're just solving for theta, so I'm going to take the inverse of sine on both sides. So sine inverse of sine of theta equals, again, what I do to one side I must do to the other. So sine inverse of 3 over 5. Those sines are going to cancel out. I'll just be left with that theta equals sine inverse of 3 over 5. You plug that into your calculator and you're going to get theta of about 36.86989. I'm just keep going. 765. You can just round that off to 36.7 degrees is fine, right? So we've got that reference angle of 36.7 degrees. What did I say? Oh, I rounded that wrong. 36.9 degrees. Anyway, that is how we use our inverse sine. Let's look at doing some inverse cosine. All right, so I've got some inverse sine questions. They're actually like the same triangles as was before. We may find out something pretty darn cool. Anyway, let's get started with inverse sine. It's going to be the same steps. And again, I think it would be helpful if we just write the cosine for this first one. Just write the cosine equation out, right? No, not sine. Cosine. Cosine of our angle, theta, equals, here it's, again, SOHCAHTOA. So it's adjacent over hypotenuse. So our adjacent side is 18.4 divided by our hypotenuse of 22. And then we're asking to solve for theta. So to get theta by itself, I have to take the inverse of cosine on both sides. So I'm going to take the inverse of cosine on both sides. All right, what do you do to one side, you must do to the other. So I also have to take the cosine inverse of 18.4 over 22. That cosine inverse and cosine are going to cancel out. I'm just left with theta equals cosine inverse of 18.4 over 22. If you plug that into your calculator, you are going to get a theta of about 33.2419. Okay, so that angle measures at about 33 degrees. This next one here, again, let's just write out our cosine equation. So cosine of theta is 55 over 73. And then to solve for cosine, I'm going to take the, to solve for theta, I'm going to take the inverse cosine of both sides. So cosine inverse of, and this is a lot to write out, but again, I would say just take it step by step until you get the hang of it here. And please do make sure to show all of your work on the assignments, please, please. That cosine inverse and cosine cancel each other, and I'm just left with theta equals cosine inverse of 55 over 73. And then I can type that into my calculator. Cosine inverse of 55 over 73 is, you get a theta of about 41.11209 degrees, all right? So that one measures about 41 degrees. Okay, and then this last one here, oh, I just got rid of my triangle. There it is, okay. This last one here, the same thing. We're going to use cosine inverse in order to find that theta. So I'm just going to write my cosine ratio real quick. Cosine of theta is adjacent of 4 over my hypotenuse of 5. To solve for theta, I would take the cosine inverse on both sides. And that cosine inverse and cosine are going to cancel out. I'm just left with theta equals cosine inverse of 4 over 5. 4 over 5, you plug that into your calculator for the cosine inverse, and you're going to get a theta of about 36.86989 degrees. All right? So, and if you think about it, we just did 2 different ways to find all of those angles. Okay, it's going to be kind of small here, but I had a reference angle here and a reference angle here. We used sine inverse and we used cosine, and we came up with the same degree measure. Okay, it's not the same in this first one because I had to round it when I did Pythagorean theorem to find that first side length. But for the rest of it also checks out, right? Again, we found theta over here. We had the same theta. We did 2 different ways to solve for that angle measure, and we came up with an angle measure of 41 both times. Same with the last one. I'm using the same reference angle in my triangle. We used 2 different methods. We came up with 36 and 36 degrees. So this all checks out, which is pretty cool. I don't know, I just think this is really nice. I love math, but you already knew that. You should love math too. Here's our little word problem for the day. Let's wrap this up nice and quickly. I've got a hot air balloon. It's only allowed to go up a certain maximum. Just pause the question and read it for yourself, all right? Basically, we've got this maximum distance of 50, all right? 50 feet, and then we have this distance, the cable, right? The thing's tied to a cable of 65 feet. I'm just going to bring that triangle out so we can actually see it real quick. And we're asking, what is this angle B? What's the angle that this wire makes with the ground, right? So here's my theta. I have a 65 degrees. We know that this thing is perpendicular to the ground, and we have a maximum height of the balloon of 50. I'm asking, what is the measure of angle B? What's the measure of this theta that we have in our triangle here? Well, if you look, I'm involving two side lengths. This one is my opposite, in reference, in context to my reference angle theta. This 50 is considered the opposite side, and the 65, well, it's opposite of my right angle, so this one has to be my hypotenuse. In my SOHCAHTOA, that's supposed to be an A, in my SOHCAHTOA thing, which trigonometric ratio compares my opposite and my hypotenuse? Well, opposite and hypotenuse here, I'm going to have to use sine, right? So I'm going to set up a sine equation down here and say sine of theta equals 50 over 65. And again, I'm just trying to solve for theta here, so I'm going to take the sine inverse of both sides. So inverse sine of this side and inverse sine of this side is going to, well, those are going to cancel out just like what we did. I'm going to be left with a theta. I'm going pretty quick here. Theta equals sine inverse of 50 over 65. And then you can just type that into your calculator, just like what we did here. And you're going to get an angle measure of about 50.285 degrees. And I'm just going to round that to about 50.3 degrees. Smiley face, woohoo! Inverse of cosine and sine. All right, so I'm going to throw you some questions. I'm going to try and find one, a cool little word problem one. Otherwise, go team. Thank you, thank you. Rocking on. You guys rock. Seriously, if you've made it this far and you're listening right now, I want to thank you so much. Tell your friends, tell your peers, tell your classmates to get on Google Classroom, to get on the YouTube channel and watch it, because it's good, because we're doing math. And I'm really jazzed. I love trig. This is pretty darn cool stuff. I hope you're excited too. I'm going to sign off. Goodbye.
You don't know how to play though.